I'm really pleased to be here today and to talk to you about a topic that I normally don't talk about so much, and that's the issue of food security, meeting the grand challenges of animal agriculture on the environment and food security. And I have to say, Sarah Place and Ty Beal have done a great job. There is some overlap here for sure. I will focus my discussion really more around some of those trends we see globally with respect to the development of human population, some food security issues, some international issues around food security in developing countries, and some environmental issues, as well as present you with a case study from the place where I reside, which is California. Because the approaches of addressing some of the environmental concerns are, of course, very, very different throughout the world. Now, you've heard this discussion many times, the discussion around the 2050 challenge, which is a discussion of a drastically growing human population. But to put it a little bit in other words, in different words, since 1920, so approximately over the last 100 years, human population on this planet has quadrupled. We went from 2 billion to now 8 billion people in 100 years. And you really have to let that sink in. Because this is really what the 2050 challenge is about, to really project where we are going globally with respect to human population, and then how we satisfy the nutritional needs of that growing global population. Now, there has been some news recently that will change the trajectory of graphs like this, but let me first walk you through this, this graph here. On the x-axis, you see the years 1750 to 2050, hence the name 2050 challenge. And what you see here is human population in billions. When I was a little boy, we were here at 3 billion. Today, we are at 8 billion. And by the time I'm an old man, we'll be at 9 or so billion people. And as you can see here, there are two colors. The one is brownish, and that's the human population in developed countries. And as you can see, that is largely plateauing. Whereas in developing and emerging countries, human population is still drastically growing. Not so much a result of people having 5 or 10 babies, but more a result of increasing life expectancy of people. So people or populations that used to grow only up to 60 or so now really live much longer. And cumulatively, that has an impact on global population. This is one of my favorite slides here. It shows a satellite image of the world and a circle over Southeast Asia. And this circle contains more people in it than the rest of the world combined. More people live inside than outside the circle. So clearly one of the hotspots in the years to come with respect to feeding the global population. But as this slide here shows, not the only one. What you see here is population increase throughout the world. And while Southeast Asia will increase roughly 41%, Africa will increase by almost 50%. The Americas are relatively stable, and Europe will slightly shrink by 2050. That is the projection as we see it. So two main hotspots in food security in the next decades to come, and that's Southeast Asia and particularly Africa. And speaking of Africa, countries that you see depicted in red here are those where human population increase exceeds 100%, meaning every 10 years, population in these red-marked countries will double. Every decade, the population will double. But the food supply, the food production and supply in these countries is not living up to that. It doesn't double at all, but it's, in the best case, plateauing. And that's really where we see food security becoming a major issue. This slide here, an FAO depiction from Livestock's Long Shadow, the infamous report from 2006, shows the global distribution of cropland. And as you can see, there's not very much marked here in color. That means we are quite limited with respect to the arable land that we have to grow crops for both human and animal consumption. I really like to do the following depiction, and so I just have to do it here too. Imagine this sheet of paper here being what you see here, the size, the surface of the entire Earth. I will now fold this sheet of paper, and I fold it twice. And what you see then is approximately the amount of land in the world. The difference between the whole sheet and this is water and ice. So this is all the land we have available in the world. And this here is my business card, which is the approximate amount of land we have in the world that's agricultural land. So this is all land in the world, and this here is all agricultural land in the world. And now I take my business card and I fold it into one piece that's 2/3 and one that's 1/3, and then I rip my own business card into pieces. Again, this is all agricultural land, and the 2/3 piece is all marginal agricultural land. And as Dr. Beal alluded to, marginal means it's too rocky, too hilly, too dry, not fertile enough. For whatever reason, you cannot grow crops here. And that's true for 2/3 of all agricultural land. Again, it's called marginal. And what do we do on this land right now? What kind of food production occurs there right now? The answer is quite easy, largely grazing with ruminants. And the reason why we use that land for grazing with ruminants is because these animals are the only ones that can make use of what's growing there, which is largely cellulose-containing forages. If we wouldn't use this 2/3 piece of land for animal agriculture, then we wouldn't use this land at all, by and large, for food production. And that, to me, is something that we cannot forgo. The remainder of my business card, this 1/3, is the total amount of arable land in the world. Here we can grow crops for food, for humans and for animals. And that's how limited we are. And I really want to emphasize that, because when you think of food security, rationalizing that we have quadrupled human population in 100 years, and that this is how limited we are in growing crops, we cannot afford of foregoing such an important landmass that helps us nourish a global population. This slide here shows on the x-axis milk production per cow per year. And on the y-axis, it shows the carbon footprint pretty much per unit of fat and protein corrected milk. And every little diamond here depicts one country in the world. So what you can see here is there are many countries throughout the world where milk production is very small, very low. And the carbon footprint of milk production is very high, because a lot of the nutrients that are fed to those animals go into maintenance, just to keeping those animals alive, but not really to producing milk. What you see here too is that the more the animals produce, the more milk the animals produce, the more the carbon footprint is diluted down. And so what you see here pretty much is that there are countries with 9,000, or the United States has 11,000 kilos of milk per cow per year. And that is having an effect on not just the carbon footprint, but also all the other environmental footprints. Production efficiencies and environmental emission intensities are largely inversely related. And that's really important, because in many developing countries, production efficiencies are extremely low. The Intergovernmental Panel for Climate Change estimates that anywhere between 70 to 80% of global livestock emissions, and now I'm talking greenhouse gases, stem from developing countries. And 20, maybe 30% from developed countries. And that is largely a result of what you're seeing here. While we have about 9 million lactating dairy cows here in the United States, in a country like India, there are about 300 million. And these numbers could go drastically down if those animals were more productive. What I'm not saying here is that the whole world should follow US examples. I'm not saying that at all. But what I am saying is that there's huge room for improvement throughout all regions in the world, and that would have a profound impact on livestock emissions in various parts of the world. Talking of various parts of the world, on this slide here, you see various parts of the world. And again, the dairy example for greenhouse gas emissions in CO2 equivalents per unit of fat protein corrected milk. You see here various areas throughout the world and the carbon footprint the dairy sector has. Now, this is not a finger-pointing exercise saying, look, we are doing it so great and there are other places in the developing world that don't. But this is pointing at there are areas with very significant room for improvement. And that room for improvement is particularly in Northern Africa and Sub-Saharan Africa and South Asia, just in those areas where we see the greatest human population increase. There's no doubt in my mind that we have some hotspots in the world. And if they follow the current trajectory, there will be true hunger. There will be real malnourishment. There will be crisis in the years to come. We are already seeing it today. We are seeing it if you go to places like the one where I'm from. I'm originally from Germany. You see that there are millions of people streaming from areas like that, where the nutritional base is no longer there, into areas where nutrition is provided, for example, Europe. A few trends in the US, it's not new to most of you. We used to have also much larger herds here in the United States. On the dairy side, approximately 25 million cows, dairy cows, in 1950. Today, we are down to 9 million. So we went from 25 to 9 million. But with this much smaller herd we have today, we are producing about 60% more milk, meaning the carbon footprint of a glass of milk in this country has shrunk approximately by 2/3. On the beef side, we used to have 140, and today we have 90 million beef cattle approximately, but we are producing the same amount of beef with this much smaller herd. Again, just an example that it's possible to produce what people demand with relatively fewer animals. I spent a lot of time in China, not recently, but prior to COVID I did. And I always found China a fascinating country insofar that they're really on the verge of moving from developing to emerging to a developed country. But there are some issues in and around animal agriculture that make my head spin. And this is one of them. About half of all pigs in the world live in China. 1 billion pigs are produced in China per year. So that's half of the world's pig production. But what I find more staggering than that is that of the 1 billion pigs they produce, 400 million pigs die pre-weaning. They have a pre-weaning mortality of 40%. And that is China. I mean, everybody here knows that country is already pretty far developed, many would agree. But they have a 40% pre-weaning mortality. And I can assure you it is much worse in many developing countries, true developing countries. So there is a significant need for knowledge transfer, for also technology transfer between those parts of the world where livestock and food production in general is working well and pretty seamless versus those where that's not the case. So China is just one of those examples that I'm picking out because it is so blatant to me. You know, 40% pre-weaning mortality is something I have a hard time wrapping my mind around. So how can we improve? How can we achieve a herd size reduction in and around the world, because many herds are extremely large, without affecting food supply, without shrinking food supply, because we need to increase food supply? Well, there are four main tools that need to be focused on globally, but particularly in developing countries. It is the issue of reproduction in the first bubble here. Reproductive efficiency is very, very poor, particularly in developing countries in the livestock herds. The herd health is a critical issue. In many developing countries, veterinary care does not really exist at a level to speak of. So animals are not prevented or treated for diseases, but are really decimated by various health conditions. The genetics can and must be improved, particularly in developing countries, as well as the feeding. Feeding more energy-dense diets, along with the other three main bubbles here, will allow us to drastically decrease the number of animals we need to satisfy food supply in these countries. Now, while that's true overall across the world, but particularly in developing countries, and while that's true for having happened in most developed countries, there are some aspects that are different in developed countries from this overall frame that I just described. And I want to give you a little California case study because we are very active in the environmental arena in California. You might have heard that we have ambitious goals in the state. It's not new to you that the dairy sector is large and therefore contributes to a lot of the state's methane. About almost half of the methane comes from our dairy sector. And our state has outlined a 40% reduction goal for methane, 40, to be achieved by the year 2030. So that is probably the most aggressive goal you'll find worldwide. That amounts to a total of 7.2 million metric tons. Just remember that number 7. Okay, it's approximately 7 million metric tons that need to be reduced to achieve that 40% reduction. So when our farmers learned about that, they wondered, how in the world can we possibly achieve such a strong reduction? My colleague Ermis Kipriap and a second colleague and I, we wrote a white paper. And if you are interested in reading it, this QR code here will get you there if you want to take a photo. It describes how in the state of California, we manage to achieve this really aggressive reduction goal by working in a voluntary and incentive-based manner. So what I'm saying here is we're not using the cane approach of rules, regulations, fines, or taxes to make farmers reduce emissions, but we are using the carrot approach of financially incentivizing methane reductions. In other words, you get paid for reducing methane. And surprise, surprise, it looks like the carrot approach is working. And from my travel throughout the world, I can tell you the cane approach, not so much. And that's true for the Netherlands, it's true for New Zealand, it's true for many other places in the world, where the cane approach doesn't seem to have the same effectiveness. So this white paper I just talked about looks at how we go about reducing methane in the state of California. So in a more modern and intensive environment. I already told you we have a goal of reducing 7 million metric tons approximately. Since 2015, a couple of, I mean, when I say a couple, officially it's 120, in reality it's now over 200 lagoons were covered. So this is a dairy lagoon here. It used to be open and off-gassing gases from the manure into the air. Now more and more of these lagoons are covered. And what you see bulging out here is biogas, 60%, 60 of which is methane. And instead of just losing methane to the atmosphere, that methane gas is now purified. And then this biogas is converted into what's called renewable natural gas, RNG. And that renewable natural gas then makes its way into the transportation fleet, into heavy-duty trucks, into buses, and so on, replacing diesel. So you're reducing emissions on the farm and you're reducing emissions in the transportation sector. Our state considers that a double whammy, and it is a double whammy. And farmers who produce this biogas now, in addition to selling milk, are selling their carbon credits. That is an additional income stream of significant magnitude. So much so that I would say this is kind of a new gold rush in California. Except for it's not gold, it's the black gold. The manure that's now not wasted or just used as fertilizer, but also prior to being used as fertilizer, the energy is extracted to be made into fuels that replace fossil fuels. So our dairy sector so far has achieved 30% of the reduction goal that they are set out to achieve. If you want to know what the other means are for us achieving that 40% reduction or 7.2 million metric tons, they are listed here. So because our cows are becoming more and more productive over time, we have had some attrition. Our herd sizes are shrinking, but slightly so, about 0.5% per year. Okay, so we have a slight attrition, and that attrition amounts to the first range here, 2.6 to 3.3. Then we are quite aggressive in covering these lagoons. They are called anaerobic digesters, and they will amount to over 4 million metric tons. So of the 7 million metric ton reduction goal, the attrition amounts to this, the digesters to about 4 million metric tons. Then there are some other alternative manure management practices. And then last not least, in the future, we'll have enteric emission reduction strategies, meaning the use of additives, feed additives. Currently, they don't play a major role, but in the future, they're likely to. And cumulatively, if you add all of this up here, we will achieve a reduction of anywhere between 7.6 to 10.6 million metric tons. In other words, we will achieve that 40% methane reduction by working with and not against farmers. And by incentivizing reductions of methane. Don't mistake that as subsidies. These are not subsidies. These farmers are producing a new product that they are selling on a market. So California has established a carbon trading market that allows those farmers to sell that new product. And our farmers are on board. To me, that is a really interesting model, one that other states should look into, and I know they do, and many other countries do as well. So what I'm telling you is I do believe that it's very likely that we can drastically reduce not just the carbon footprint of livestock globally, but all environmental footprints by drastically improving efficiencies. That's particularly true for developing countries. In developed countries like European countries and here in North America, we have significant potentials in the area of manure management, enteric management, meaning feed additives, but also in the area of genetics. There are now efforts to establishing low methane dairy cows, low methane beef cattle, low methane everything. And that would be a permanent reduction of the warming impact that those animal species have. So genetic is one approach. There are other approaches that are currently being investigated, one being vaccination for methane. The New Zealanders are working on this. It's not that they have something on the shelf at this point, but they've been working on this for the last 20 years. And they are still bullish about achieving that. And then there are also some other technologies, for example, the use of a bolus that you lodge in the rumen of a ruminant animal that slowly releases an active ingredient, reducing methane. So in developed countries, I do think there will be a whole host of tools in our toolbox to reduce methane, but also other issues. For example, nitrogen. We must not forget, while we talk about methane in this state and in this country all the time, that is not the only issue. An issue at least as important as methane is nitrogen. And you will see in 5 years, we'll have meetings like this about reactive nitrogen. It's one of the biggest topics in Europe now. It will be a big topic here, as well as water. Let's not forget water. Water is such an important, such a critical issue. And there are more and more regions throughout the world where the scarcity around water is critical. So with respect to gaps, I do think that we really have to think about particularly developing countries and how to reduce the livestock impact that they have, because it's massive due to herd sizes. In developed countries, I do think that we need to work on not just technologies, developing those technologies, but establishing markets for these technologies. Because if people cannot pay for them, they will not implement them. There have to be markets. There have to be incentives. And to me, one learning is the carrot approach works. To have incentive-based approaches that are voluntary, that works. And working with farmers to achieve proper outcomes is something that works way better than just shoving it down their throats. I just, as my last slide, want to point out that one issue that's oftentimes overlooked is depicted on this National Geographic photo here. You see here a US family in front of the food waste associated with them, but 40%, 40, of the food we produce in this country is never making it through a human digestive tract. What I find shocking is that not just does this apply to the United States, but to all developed countries and even to developing countries. But the difference between developed and developing countries is that in developed countries, the food waste occurs at the consumer level in our kitchens or restaurants. Whereas in developing countries, it's called food loss, and it occurs more at the producer level, producers being unable to harvest on time or ship their goods to the markets and so forth. But 40% is a rough number globally of food that's produced but never eaten. And I think we should all agree that that is absolutely intolerable and certainly something that we can do better on. So with that, this is not a topic I talk about all the time, in fact, hardly ever, but I hope that I gave you a little bit of a great overview of this topic, and I'm looking forward to questions that you might have later. Thank you very much.